Okay, now this is sort of a common sense question. It's why do reciprocals of linears always have vertical asymptotes and quadratics sometimes do and sometimes don't? Okay, well, this helps to know what linears always do. A line, other than, and we have to be careful because there's one exception to this rule right here, but you'll never see it anyway, is a horizontal line that's above the x-axis will not have a reciprocal. It will be a vertical line. But that said, all other lines, if you notice, either go down like that and cross through the x-axis or up like that and cross through the x-axis. That means either of these lines at any point, no matter which one we use, has some negative values, right? It also always crosses the x-axis. That's actually the important point. Forget the negative values. Always crosses the x-axis, which means at the x-axis, y is 0. When we take a reciprocal, we're really taking the reciprocal of the y values. That's what I tried to show you quickly with the quadratic before. And when it hits that x-axis, when we have a y value of 0, we're taking 1 over 0, which is impossible. And that's what a reciprocal really is. I'll give you some math examples. But then the question is, well, why doesn't a quadratic always have a vertical asymptote? Well, any quadratic above the x-axis or below the x-axis will have no vertical asymptotes because they never cross the x-axis where y is 0. For those quadratics that do cross the x-axis, they essentially have two factors, don't they? That's what x-axis intercepts are. They're two factors. And thus, they will have always two intercepts, two vertical asymptotes, rather. Any quadratic that touches the x-axis once will also have one asymptote. Let's look at an example. So let's just take a line, 2x plus 4. Or 2x minus 4 is a better example. Actually, either one works. 2x plus 4. The question becomes, when is that 0? When is that equal to 0? Well, we subtract 4 from both sides. And then we divide by 2. We discover that's 0 when x is minus 2. In other words, when this is minus 2, this whole thing comes out as 0. Well, that's fine. That means the line, that particular line, will cross the x-axis when x is minus 2. We can use that visually if we want. But now let's imagine what happens when we put that 1 over that. 1 over that. When we do 1 over that, the only thing we can never, ever, remember this is the rule, the only thing we can never have as a denominator is 0. That means this whole thing cannot equal 0. That means when x is minus 2 here, this whole thing does equal 0. So what we will see is an asymptote at that point. An asymptote at that point. Let's have a look. So here's the line 2x minus 4. We can see, it's plus 4. We can see that it indeed crosses the x-axis. As soon as I get there we go. We can see it indeed cross the x-axis at minus 2. And the point is, if I put 1 over that, we will see a vertical asymptote at that point. And sure enough, let's put the vertical asymptote, x is equal to minus 2 here to see it more visually. Yeah, we can see that the line 1 over that red line produces an asymptote right where it crosses the x-axis. Let's find another spot. If I make this, I'm going to turn these off. If I make this plus 6 here, it's clear that when x is minus 3, it comes out as 0, which means when this graph exists, we will have a vertical asymptote at x is equal to minus 3. There we go. We can see the red line. It does indeed go through the point minus 3 comma 0. When we turn on the reciprocal drawing, we see that it has a vertical asymptote at x is equal to minus 3. So we can see wherever a line crosses the x-axis, that's where the asymptote is going to be created. Let's look at a quadratic that's above the x-axis. Let's try one where we can see it. There we go. This quadratic only has positive values of y. That means if I take 1 over it, the bottom denominator will only come out as positive values, which means 1 over a positive value will always be a positive value. Thus, I will have a purple graph like that. And notice the connection point is the vertex. However, if I have this quadratic that touches the x-axis, I can see the y is there. So when x is minus 2, I can see that y is 0. That means the 1 over that quadratic will have a vertical asymptote at x is equal to minus 2. So that means, yeah, in this case, the quadratic has one spot where a 0 is possible. Thus, it will create one asymptote. However, if that quadratic is above the x-axis, you will never see a vertical asymptote. You'll see just this weird bump, and then down we go. If we have a quadratic that has two, we can see it has two factors. We can see that the factors are even these, x plus 3 and x plus 1. This will be the same quadratic. So we can imagine that if we have 1 over that, neither of those brackets can be 0. Therefore, we will have a vertical asymptote at x is equal to minus 3 and x is equal to minus 1. I'll turn off the visuals. I'm going to turn off the red. I'm going to turn off the blue. There's the 1 over version, sure enough. And we can see where it shares, where those vertical asymptotes happen is where the parabola is hitting the x-axis, which produces a y value of 0. 1 over 0 can't exist. Therefore, that's why 1 over these factors, if either of these brackets is 0, this fraction cannot exist. It's why we have quadratics that are across the x-axis will have vertical asymptotes, and quadratics that don't will not. So actually, I'll maybe put that 4 back just to show you what happens if I, no, 3. Yeah, and I'll take that and put it over instead of the fact. It's the same drawing, it's just one is in factor form. See, it came out as the same drawing. We can see the connection. Wherever the parabola crosses the x-axis, that's when the vertical asymptote happens. But again, if you have a parabola that does not cross the x-axis, you will not have vertical asymptotes. However, I'll get rid of those vertical asymptotes because they don't exist in this one. However, lines, doesn't matter what line it is, 2x plus 3. Let's have a look and see if we can predict where the vertical asymptote is. It's going to be exactly at minus 0.422. So if I put 1 over 7x plus 3, we're going to see, sure enough, a vertical asymptote at minus 3 over 7. Right there. How did I come up with that? Well, it's when this is equal to 0, subtract 3 from both sides, minus 3, divide by 7, minus 3 over 7 is what x has to be to come out with 0, and 0 cannot exist down here. All lines, even if I make this negative, now the vertical asymptote will be on the positive side. Well, maybe not. Let's see, it'll be 3 over 7, but I forgot to change it down here. Sure enough, we can see when this red line, and I'll turn off the asymptote, when this red line is here, that's when the vertical asymptote happens, because the y is 0 and 1 over 0 cannot exist. So that's the connection between all lines and their reciprocals. There will always be a vertical asymptote. Parabolas can have a vertical asymptote. They can have 2, 1, or none, depending on whether they cross the x-axis.